Okay, this is my little three-phase motor. I'm using the red coils as my drive coils. These here. These are just little coils to generate electricity. And so the red are drive coils. The gold ones are just to generate electricity. The red ones are 1 pound, 24 gauge. And the gold ones are a half a pound, 24 gauge. The gold ones aren't putting out very much power for whatever reason. I think they just need a lot more turns on those coils. Anyway, this here is just a little rectifier circuit. I can give you a better idea. It's upside down of what you're looking at here. If you want to try one of those, you can just do a little print screen and print that out and have it for yourself. The way the coils are wound for the motor, I'm trying them in a delta configuration. And there's a copy of that if you want to try that. I get a lot more speed and torque with the delta, but it uses a lot of electricity, a lot of wattage to run this motor. And then I'm using an 18-volt Ryobi battery to drive the motor. And I'm experimenting to try to find what is more efficient, actually. And this is far from efficient, but it's fast, and I just wanted to show it. This here is a little three-phase motor controller. Comes with a little pot to adjust the speed. And I'll start it up. And it gets up there pretty good. Can give you an idea. That's upside down, so that's 4,500 going on, about 4,600. I'm going to slow it down. I'm going to see if I can hook up some lights with one hand. Turn it back up. You can see this is kind of upside down. This is not very good. I don't know if you can read that, but that's 56. It's bouncing around the 50-watt range, so it's using a lot. It's only putting out probably about 1.5 watts. So like I said, it's far from efficient, but it runs, it's fun. So I'm gonna do some other coil configurations and some other size coils and play with it, and I'll get back to you. All right, hope you enjoyed it. I forgot to mention how this was made. This wheel here has holes drilled inside of it in 4 places, spaced equally around the wheel, with neodymium magnets that look like this. 6 magnets in each hole, so there's a hole drilled about the size big enough to stuff these in. Whoa. And here's a bigger one I had made, and you can see, and they're just epoxied inside. So one of the things that I'm concerned with is, at one time the magnets flew out. I think I was somewhere over 4,000 RPMs, and the force of that wheel spinning just threw these damn things out. I'm lucky they didn't hit a window. They hit one of the coils and broke it loose, broke the the tie and broke the coil. I mean, there was a lot of force coming out, so be careful when you're experimenting with these things. Thank you again. Okay, now we're back with a different coil configuration. I've changed the coils from a delta wiring to a Y configuration. This would be your Y. So each coil has one of these wires from the controller going to the coil. 1, 2, and 3. The other end of each coil is tied together, so they just common up on the other end of the coil. So that's what we got now. We're still using the red coils for our drive coils, and the gold coils are just to generate power, which they're putting out not very much right now, because with this configuration I don't get as much speed or torque enough to put out hardly anything, so I'm not even going to bother with that end of it. Just showing you the difference. We were at 4600 RPMs in the delta configuration. Remember, this is upside down, so we're getting about 2400 now, maybe just a little over 2400. The good thing about it is that we're only using, it's bouncing around 6-7 watts versus whatever we were at before, but I'm sure it was 4 times as much as that. This meter's not even reading an output from the power generating coils. That needs, I think, about 7 volts before it even starts up. I'll be back with the next setup. Now we're using our smaller coil, the half-pound 24-gauge coils as our drive coils, and the larger 1-pound 24-gauge coils as our generating coils. And I'll crank it up so we can do a little comparison. It's not nearly as fast as the previous setup we had. So it looks like we're getting pretty 2900 RPMs. It's bouncing back and forth right around 2900. And as far as our wattage, you can see that 13 watts compared to the previous 50 watts. And we're putting out about 1 watt. Hope you can see that okay. So this is a little more efficient, quite a bit more efficient anyway. Not as fast, not as much torque, but efficiency-wise, we were putting out 1.5 watts, but we were using 50 watts. So in this case, we're putting out 14 watts to get just over 1 watt. Okay, thank you for watching. And if you like the video, go ahead and hit the like button for me. If you have any comments, I'd appreciate it. Like I say, I'm looking for efficiency, so anybody with ideas, I'd be glad to hear them. Thank you. Have a good day.